In this lesson, we want to talk about how to find the adjoint of a matrix. So when we talk about the adjoint of a matrix, which is also referred to as the classical adjoint if you're in a linear algebra course, or the adjugate, it's found using kind of two easy but I would say tedious steps. So the very first thing you want to do is make a matrix of cofactors. Now, we talked about cofactors when we did our lesson on determinants, and specifically when we looked at our method known as the kind of Laplace expansion method or the kind of expansion by cofactors method. Now, after you've kind of got your matrix of cofactors, the next thing you want to do, or the second part of the process, is to find the transpose of that cofactor matrix. So like I said, it's two easy steps because you're basically just doing some arithmetic, but it's quite tedious, especially if you get into something like a 3x3, a 4x4, a 5x5. These are kind of matrices that when you find the adjoint for them, it takes a little bit of time. So without further ado, let's just look at an example real quick. And we're just going to start out with something that's very generic. And I'm going to show you that you've seen the adjoint of a matrix already. You just didn't know it. So first, we have our matrix A, and it has A and B in the first row and C and D in the second row. Now, we already said that the inverse of A, the little shortcut method was 1 over the determinant of A. Okay, so that's why I have those vertical bars surrounding that A there, times, it's going to be the adjoint of A. Okay, so this is the adjoint of our matrix A. What we're going to do is we're going to swap these two. So I'm going to swap A and D. So D comes up here, A goes down here. And then these two, the C and the B, I'm going to make them into their opposite. So I'm going to put a negative B and a negative C, just to say, hey, whatever we have in those positions, we're going to take the negative of it or just change the sign. Now, this is the ADJ of A, or again, the adjoint of A, or the adjugate of A, however you want to think about that. So where did this kind of come from? Well, again, what we could do is we could start out with this guy right here. We could make a matrix of cofactors, and then we can take those cofactors, that matrix, and we can find the transpose of that guy, and it will give us this exactly. So to see that real quick, let me just kind of copy this. Let's go to a fresh sheet, and I'm just going to paste this in, and let me just kind of clean this up a little bit. So what we're going to have here, I'm going to put ADJ of A is equal to this. Okay, so our original matrix A was what? It's A, B, C, and D. And the reason I'm going through this generically is that once you kind of look at this, you'll know the shortcut for a 2x2 to find the kind of adjugate, or again, the adjoint. And you can quickly do it with a 2x2 just from that shortcut. When you get to a 3x3 or higher, you're going to have to do more work, and I'll explain why in a little while. So the very first thing with this guy is to make a matrix of cofactors. Now, when we talk about a cofactor, remember there's kind of two parts to it. The first part is you have to calculate a minor. Okay, so how do we find the minor? Well, let's say I wanted the minor of this element here. I would delete the row and I would delete the column, and I would look at the determinant of the matrix that's left. Well, if you do this with a 2x2, the determinant of the matrix that's left is just the entry that's left. Because the determinant of a 1x1 matrix, if I wanted the determinant of this, it would just be this itself. So when you work with these, you're just grabbing the entry that's left. That's all you have to do. But if you go into a 3x3 or higher, you're going to end up having to actually go through the work of finding a determinant, because it's not just going to be the single entry that's left. Okay? So what we want to do is say that the minor, and I'm going to notate this as M sub 1, 1, because again, this is row 1, this is row 2, this is column 1, this is column 2. This is telling me I have the minor element for row 1, column 1. So it's this entry right here. And what is it equal to? Again, if I mark out this row, mark out this column, it's the determinant of what's left. In this case, it's just D. Okay? So that is how I find the minor. But that is not the cofactor. There is an extra step. And there's a few different ways you can do this. Let me show you the long way, and then I'll show you how to make like a little sign table so you can speed this up. So the cofactor, C sub 1, 1, okay, so of this entry right here, you take the minor and you multiply it by -1 raised to the power of the row plus the column. So in this case, you can get that information from here. So 1 plus 1 is 2. Now notice how if you're raising -1 to an even power, you're going to get 1, and the sign of the minor is not going to change. So this guy is equal to +1 times d, which is just d. So the cofactor for this kind of entry in row 1, column 1 is just going to be d. So let's erase all of this. And let's put that c is equal to, okay, we're just going to put a d here to start. Now, for the rest of these, if you want to kind of make it a little bit quicker for yourself, when you set up the kind of cofactor matrix, instead of having to go through and multiply -1 raised to the power of the row plus the column each time, you can predetermine the signs. You'll see a lot of different sign charts out there, and basically they alternate. So again, if I look at the kind of row and the column I'm in each case, this is a row number of 1 and a column number of 1 right here. 1 plus 1 is 2. 2 is an even number. So we know -1 raised to an even number, okay, is going to be +1. So the sign is going to be positive or just stay what it is. Okay, that's what that means. Then if I go here, it's going to be row 1, column 2. 1 plus 2 is 3. It's negative. See how it alternates? Then if I come down here, it's row 2 and column 1. So it's 2 plus 1, which is 3, which is odd. Okay, so again, that's going to be negative. And this last one is row 2, column 2. So 2 plus 2 is 4. That's even, so it's positive. So if you have this as a little reference, you can find your minor and just attach the sign that way. So you don't have to go through and multiply by -1 raised to kind of the power of the row plus the column each time. So let's just keep this here for reference, and let's just burn through the rest of this. So if I want the minor for this guy, again, all I do is I delete the row and the column it's in, and I take the determinant of what's left. In this case, it's going to be C. And for this one, let's delete the row and the column, and I'm left with B. And for this one, I'm going to delete the column and the row it's in, and I'm going to be left with A. Now, we already did the sign change for this one. There was no sign change. But for this one, notice how, again, there's a sign change. So I'm going to put a negative here. For this one, there's a sign change. So I'm going to put a negative here. And for this one right here, there is no sign change. So when you have a plus, you don't change the sign because the minor and the cofactor are the same. But when you have a minus, you do change the sign. So you want the negative of whatever's there. So this is the cofactor matrix now. We've taken all the minors and applied the sign changes when they were necessary. Now, to get the adjoint, you'll notice that this is still not the same. The entries along the diagonal are the same, but these two are not. So what you have to do is take the transpose of this guy. So the transpose of C, and we put that capital letter T, the superscript above our kind of letter C there to show this. All we need to do, this is a very simple process, we take the first row and make it the first column. So we'll take D and -C. Then we take the second row and make it the second column. So negative, B, and A. So basically, if you've never taken a transpose before, you're just interchanging the rows and columns. So I took the first row and made it the first column. The second row became the second column. Now, another way you could do this, you could say that the first column became the first row and the second column became the second row. So however you want to do that. So I'm done with this matrix here. And basically at this point, I can say that the adjugate or the adjoint of our matrix A is equal to the transpose of our matrix C, which is this guy right here. And you'll notice that these two match up perfectly. You've got a D and a D. You've got a negative B and a negative B, a negative C and a negative C, and an A and A. So what happens is when you work with the 2x2 matrix, you can always use this little shortcut by just remembering the generic entries here and remembering the adjugate, or again, the adjoint turns into this one. So these two switch, and these two on the kind of opposite diagonal are going to be their opposite. So let's look at an example real quick. So we have our matrix A, and it's equal to, we have -1 and 3 in the first row and 5 and 2 in the second row. So what we can do here, again, if it's a 2x2, it's very easy. We can just use our shortcut. So I can switch these two. So I can say this is 2 and this is -1. And I can say that these two are going to be their opposites. So this is -3 and this is -5. So look how fast and easy that is using that shortcut. Unfortunately, in a moment when we start looking at 3x3s, we've got a lot more work to do. But let's just do this the slow way real quick, just so we get a little bit of practice before we get into the 3x3 and we have something more difficult. So if I want the adjugate of this guy the slow way, I would find a cofactor matrix first. And again, let me just set up the signs. So in this kind of first row, first column here, again, it's row 1, column 1. So 1 plus 1 is 2, that's even. So there'll be no sign change. And then it alternates. So this guy's going to be negative, and then down here it will be negative, and here it will be positive. Again, just look at the sum of the row number and the column number. Row 1, column 1, 1 plus 1 is 2, 2 is even. So that's why it's positive. If it's row 1, column 2, 1 plus 2 is 3, it's odd, so that's why it's negative. Okay, so you can just look at that, sum the row number and the column number. If it's odd, it's going to be negative. Okay, if it's even, it's going to be positive, meaning there's no sign change to your minor. All right, so let's go through this real quick. If I want the minor of this guy, delete this row, delete this column. We want the determinant of this, which is just this number itself, so it's going to be 2. So let's write our 2 in there, and I'll put it in a different color. So let's move on to this one now. So I'm going to delete the row and the column. I'm left with just 5. Again, you take the determinant of that, it's just that. But notice how I put the negative 5 there. I want the opposite of this because there's a negative sign there. Okay, I'm basically just multiplying it by negative 1. Then as I move down here, I'm going to delete the row and the column. I'm left with just 3. The determinant of that would obviously be 3. But again, there's a negative there, so I want negative 3, the opposite of that number. Then lastly, for this entry here, I want to delete the row and the column. I'm left with negative 1. So obviously the determinant of that is negative 1. Okay, so we had a plus there, so there's no sign change. Again, I can't stress this enough because this is what confuses people. If you end up with kind of a negative sign there, if you're looking at a sign table, take the opposite, or you could say multiply by negative 1 by what you get for your minor. If it's a plus there, leave the minor alone. There's no sign change needed. All right, so now that we have this, we're not quite there yet because we have to take the transpose. So the transpose of C is equal to the adjugate, or again, the adjoint of A, which is equal to what? Well, let me kind of move this out of the way because we're going to run out of room. So I'm going to define this down here. So what we would do is take this first row and make it our first column. So 2 and negative 5. The first row became the first column. And then the second row will become the second column. So negative 3 and negative 1. So you'll notice this matches our shortcut exactly. 2 and negative 3 in the first row, negative 5 and negative 1 in the second row. Okay, let's look at an example that's a lot more tedious, but again, the concept is the same. So we have a 3 by 3 here, and obviously what we want to do is start out by making a matrix of cofactors, then find the transpose of that, and that's going to give us our adjoint. Okay, so C is going to be equal to, that's my cofactor matrix. I'm just going to go through and put some signs in so we don't have to deal with them. So this guy is row 1, column 1, so it's plus, and then all the signs are going to alternate. So it's going to be minus and then plus. Okay, and you can go through and see that for yourself. But then going down here, this is going to be minus, plus, and then plus, minus, plus. So the signs always alternate. Okay. So now what I want to do is go through and find those entries. So I'm going to start with this one right here. I'm going to mark out the row and the column and take the determinant of what's left. Okay, so here's where it's more work because before with the 2 by 2, you really didn't have to, you do take the determinant, but the determinant is just the number that's presented because you only have one number. Here I actually have a 2 by 2 matrix that I have to find the determinant of, so it's much more work. So I'm going to do 2 times 0, which is 0, minus, you have 3 times negative 1, which is negative 3. 0 minus the negative 3 is 0 plus 3, which is 3. Okay, so no sign change here, so this will just be 3. So let's go through the next one. So we want this one, so I'm going to mark out this column and this row. So I would have 5 and negative 4 and negative 1 and 0. And I'm just writing this out because it's kind of hard to see this with kind of this highlighting in between. So the determinant here would be 5 times 0, which is 0, minus, you have negative 1 times negative 4, which is 4. So this is negative 4, but you have a sign change there, so this is positive 4, okay? All right, so let's go to the next one. So now we're here. We're going to mark out this column and this row. So what we want to do is find a determinant of this. 5 times 3 is 15. Then minus. You have 2 times negative 4, which is negative 8. 15 minus a negative 8 is going to give me positive 23. And there's no sign change here, so we'll put just 23. Okay. All right, let's erase this. And let's do this one. So I'm going to delete this row, and I'm going to delete this column. So what we're going to have here is 1 and negative 6, and then 3 and 0. So we want the determinant of this. 1 times 0 is 0, minus 3 times negative 6 is negative 18. Again, minus a negative is plus a positive, so this would be positive 18. So we're doing a sign change here because it's right here where there's a negative. So this is going to end up being negative 18. So let me write that in, negative 18. All right, let's go to the next one now. So we're going to do this one. So I'm going to delete this column and this row. So what do we have? We have 3 and negative 6, then negative 4 and 0. So the determinant of that, 3 times 0 is 0, minus negative 6 times negative 4 is 24. So we have 0 minus 24, which is negative 24, and there's no sign change there, so it's just negative 24. All right, let's go to the next one. So now we have this one right here, so delete the column, delete the row. What's left? We have 3 and 1, negative 4 and 3. So the determinant of this guy, 3 times 3 is 9, minus 1 times negative 4 is negative 4. 9 minus the negative 4 is the same as 9 plus 4, which is 13. But again, you've got that negative there, so you've got to do the sign change. So this is negative 13. All right, let's look at this final row. So we have this guy right here. So I'm going to delete the column. I'm going to delete the row. So what I have left is this guy right here. So the determinant of that, 1 times negative 1 is negative 1. Then minus, you have negative 6 times 2, which is negative 12. Again, minus a negative is plus a positive, so it's negative 1 plus 12, which equals 11. No sign change, so it's just going to be 11. Let me change colors there. So now we're here. So we're going to delete this column and this row. So we would have 3 and 5, negative 6 and negative 1. So the determinant of this guy, 3 times negative 1 is negative 3, minus negative 6 times 5 is negative 30. And this equals, we would have negative 3 plus 30. Again, minus the negatives plus a positive. So this is going to be positive 27. Now when we look at this, we have to do a sign change. So this will be negative 27. All right, last one. So we want to find the cofactor of this guy. So delete this row and this column. So what do I have? I would take the determinant of this matrix. 3 times 2 is 6, minus 1 times 5 is 5. So this is 1. And there's no sign change here, so this is just going to be 1. All right, so now I have my cofactor matrix, or my matrix of cofactors. At that point, it's pretty easy. I'm going to say that the transpose of this cofactor matrix is equal to the adjoint of A, which is going to be equal to what? We're going to transpose this guy. So I'm taking this row and making it this column. So let me use a different color. We're going to have 3, 4, and 23. Again, first row becomes first column. Then the second row becomes the second column. So negative 18, negative 24, and negative 13. Then the third row becomes the third column. So 11, negative 27, and then 1. Okay. Now, if you want, you can delete this notation because you're done with it. If you're asked for the adjoint, just give them this. You don't need to tell them it's the kind of transpose of the cofactors because they already know that. Okay. So this would be your answer, your adjoint or your adjugate of A. All right, let's go ahead and take a look at another one. It never hurts to practice a little bit more. If this is something you're already comfortable with, you can already start doing your practice problems. Otherwise, let's go ahead and knock this guy out. So we want to find the adjugate, or again, the adjoint of A. So the first thing I want to do is find the kind of cofactor matrix. And the first thing I'm going to do, again, is just make a matrix of signs, because I know that that's going to help me, right? I don't have to go through and do negative 1 raised to the power of the row plus the column each time. So again, if you can just remember that this first one's positive, because it's in the first row and first column, 1 plus 1 is 2, raising negative 1 to that even power gives you positive 1. You just alternate from there. So this is negative, this is positive. And then you would come down here and you'd alternate. So this is negative, positive, negative. Come down here and alternate, positive, negative, positive. Very easy to remember that this first one's positive and that they alternate. So if you remember that, then you're basically good to go. Make your first row, then drop down here and say, okay, if I'm alternating, it was positive, now it's going to be negative, and you just alternate. That's how you can keep going. So once we have this kind of set up, we just go through and get our minors, and then apply the sign change if we need to, find the transpose of that matrix, and we're good to go. All right, so the first one here, to find the cofactor, delete the row, delete the column. What's the determinant of what's left? Negative 2 times 9 is negative 18. And then minus 0 times 1 is 0. So this is just negative 18. There's no sign change, so let's just put negative 18 in there. And then let's move on to the next one. So now I'm going to be here. I'm going to delete the row and the column. And let's just do this from where it is. We would take the determinant of this matrix here. It would be 6 times 9, which is 54, minus you have 0 times 0, which is 0. So this is 54, but again, you have that sign change. So this is going to be a negative 54. All right, let's move on to this one. So I'm going to delete the column and the row. And the determinant of this guy, 6 times 1 is 6, then minus. Negative 2 times 0 is 0, so this is just 6. No sign change because it's positive, so let's just put a 6 there. So let's start right here now. We'll be in the second row. So I'm going to delete this row, and I'm going to delete this column. So what do I have left? I have this matrix with negative 1 and 3 and 1 and 9. So the determinant, negative 1 times 9 is negative 9. Then minus 3 times 1 is 3. Negative 9 minus 3 is negative 12. You've got a sign change there, so this would be positive 12. So now I'm going to be here. So I'm going to delete this column and this row. So the determinant of this, 1 times 9 would be 9. Then minus 3 times 0 would be 0. So this is 9, no sign change. So it's just going to be 9. Then let's move on to the next one. So I'm going to be here, delete this row, delete this column, and take the determinant. 1 times 1 is 1. Minus, you have negative 1 times 0, which is 0. So this is 1. But again, you have a sign change there, so it's going to be negative 1. All right, let's erase this. And let's highlight this guy right here. So we're going to delete this row and this column. Okay, so now what we're going to have is the determinant of this. So negative 1 times 0 is 0. Then minus 3 times negative 2 is negative 6. 0 minus the negative 6 is 0 plus 6, which is 6. So this is 6. All right, now let's look at this one right here. So I'm going to delete the row it's in and the column it's in. And I'm going to take the determinant of this guy. So it would be 1 times 0, which is 0. Then minus, you have 3 times 6, which is 18. 0 minus 18 is negative 18. But you have your sign change there. So it's going to be minus a negative 18, or you could say negative 1 times a negative 18, however you want to think about that. It's going to be positive 18. And let me just change the color of this guy real quick. I like for my rows to have different colors. So let's do the last one. We're almost there now. So this guy right here, I'm going to delete the row and the column. And so the matrix that I have left, the determinant of it, 1 times negative 2 is negative 2. Then minus negative 1 times 6 is negative 6. Minus a negative is plus a positive, so negative 2 plus 6, which is 4. So this will just be 4 here. So let's erase this. So now we have a matrix of cofactors, and what we want to do is find the transpose of this guy, and that's going to give us our adjoint. So you can say C transpose is equal to the adjoint of your matrix A, and this is equal to, again, you can just take the first row and make it the first column, or you can take the first column and make it the first row. Let's do it a little differently. So let's take the first column and make it the first row. So negative 18, 12, and 6. Again, all I did was I took the first column, made it the first row. Now I'm going to take the second column and make it the second row. So negative 54, 9, and 18. And then the last thing I'm going to do is I'm going to take the third column and make it the third row. So I'm going to have 6, negative 1, and 4. Okay. Again, it's equally valid to take the first row and make it the first column. It's the same. You can take the second row, make it the second column. Take the third row, make it the third column. You are interchanging the rows and the columns when you find the transpose. So either way, we found our adjoint for A, and I can erase this notation. We don't really need it. This guy right here is the adjoint of our matrix A.